Hello, everyone. Good morning, good afternoon, good evening, depending on where you are. My name is Heather Payton, and I'm the product marketing lead for Chef Infrastructure Management. And I'm super excited to be here today with Jason Field, a guest presenter from ECS, for what is our 5th event in the Chef Infra Best Practices series. Today, we're going to be talking about automated chef deployments with GitHub Actions. As you can see, we've covered a number of exciting and interesting topics in the series. And I also want to mention, we also have an ebook that talks about the top 10 ways to optimize Chef Infra that I'll be posting on in the chat. But with that, we're going to just move right into the meat of today's presentation with our presenter, Jason Field. For those of you who are not familiar with Jason, Jason is a delivery consultant for ECS. ECS is a DevOps consulting company which helps organizations leverage technology and become digital leaders. Jason is also one of our sous chef board members and very active in the chef community. And so with that, I'll be turning things over to Jason.
Thank you, Heather. So yeah, nice to see you all, I guess, virtually. So I'm Jason Field. As Heather said, I'm a delivery consultant. I do sous chefs, and I've been working with chefs for a number of years now. So really, what we're going to be covering today is going to be an intro into GitHub Actions, a bit of a walkthrough, and next steps and questions. Heather, if you could move on to the next slide, that'd be brilliant. So what is GitHub Actions? So as an overview, GitHub Actions is a CI system tightly coupled into GitHub, and it's just a nice way of doing CI pipelines as code. It makes it easy to automate your CI workflows. So we do things in sous chefs around linting, unit testing, integration, and it also enables you to act upon any event that GitHub can fire. So for example, you can have actions that will fire based on the fact an issue's been created, or maybe a pull request got a label. So that will trigger a different workflow to say, hey, has this label been put on correctly? Are there duplicates in the same categories of labels? So it's about giving you that power to say, not just CI, but anything in GitHub you can automate potentially with actions. Heather, next slide, please. So what's the benefits of CI? I'm sure most of us are using it, but just to go over the normal stuff again. So it's about committing code. So you want to make a change, you basically suggest that change. You want to open a pull request to say, hey, maybe I want to change a file on disk. And then we'll automatically run some tests. Those tests validate that your change isn't going to break something else. The worst thing that you can do is commit something and break something, but not know that you've broken it. So that's why the automated testing is important. And once you've got those tests done, once somebody's reviewed your code and everyone's happy, you have that ability to merge with confidence. You know that you're not going to break anything. You know that everything's going to work as you hope. Heather, thank you. So what are the two main things that we'll be touching on today? Is a bit on linting and unit testing, and then also integration testing. So by linting and unit testing, we're talking running Cookstyle on every check-in. So Cookstyle is a linting tool. It will check the style of the chef files you've got, but also check for common mistakes and do some static code analysis. Maybe you've written some RSpec unit tests. These are less common in Chef, but some people still use them. We do it in sous chefs for specific methods that we're sharing across different recipes or different resources. So we want to check that those are still passing, that we've not done something there. And we might also use GitHub Actions to validate other file types. So maybe you've got some YAML files or some Markdown files. Just validate that they're in a common, consistent format. So the next person in knows the convention, it's really obvious to them. And if they jump between any of your repositories, it will just work. The other side of it is Test Kitchen. So GitHub Actions gives us runners for all of the major operating systems. So we have Linux, we have macOS, we have Windows, but we also have the ability to run in parallel. How many times have we all gone onto a CI system that may be testing every OS, but it's one after another. So if you're doing test kitchen integration tests, that could be, being nice, maybe 2 or 3 hours. It could be 12 plus hours, as I managed to do in Suze a couple of times. And this parallel is just about bringing that speed there, which means your feedback loops are faster. So people will be able to fix any small errors they've made really quickly with your tests. So I think let's move on to a quick demo of what we actually have in actions. So then, can I just confirm that people can see the screen I'm sharing, which should be the Sous Chef's Java cookbook?
We've got it.
Perfect. So here we have an example GitHub workflow. So on here, you'll see that it's just a file in disk. It's that whole pipelines as code. So as a developer, I can see what the actions are that's going to be run. Okay, I've just been noted. It could be good to change the background. Just give me a second. So if I refresh all of these while we wait. So is that better? Brilliant. So yeah, back to what I was saying. So this is just a pipeline as code. It means as a developer, I can see what tests and what checks are going to be run when I commit and when I issue my pull request. But that also means that I personally can go and see and maybe run these locally before I want to commit. Maybe I'll use a Git hook, or maybe I'll just decide to run them before I merge. So moving on to this. So what do we have here? We have an on. On is saying which GitHub events are we interested in. So in this case, we're saying on anything to do with a pull request. So when we push code to a branch that has an open pull request, it will trigger. And also specifically on pushes to the master branch. So we want our mainline branches to have this run again. Maybe it works on the pull request and maybe it doesn't work on master, but it's just that ability to know that the default branch, the mainline branch, is always good. Then we move into the job section. So here's where we start to look about what are we actually going to be running. So under jobs, delivery is just a name of a job. So in this occasion, we're running delivery on a Ubuntu latest machine. So as I said, there's Windows, there's Mac, there's Linux. We picked Ubuntu just because it's fast. Ruby on Windows is not as quick, and there are less macOS machines in the pool compared to Linux machines. So it makes sense for us to use Ubuntu here. Then as we move down, we'll see what an action is. So we're using here predefined actions that are provided for us. So the first action here is the checkout action. Quite common to everybody. We check out the code onto disk because without checking out the code, we can't do too much. Then we want to run Chef Delivery. Chef Delivery is a utility included in Chef Workstation that will let you run a number of tasks depending upon how you configure it. For us, this is a way of us bundling our cook style and our RSpec tasks together. And you'll see as well, we've set the Chef license as we are allowed to use Chef on the binary form for testing in our use cases in Suze. And then we do very similar things for YAML lint and Markdown lint. So again, we're checking out that code and then we're going to run a predefined action. So that's great. That handles our linting and our unit tests. But how do we do integration tests? So for us, we have two types of integration tests in Java. We have Docken, which will cover our Linux use cases, and we have macOS, which will obviously cover our Mac use cases. What we first define here is a needs. So this is saying, I will only run the Docken tests if the following have already passed. This is to do with the faster feedback loops as well. So we want to know that, hey, the quick tests have run, they were successful before we move on to the longer tests. The next thing we look at here is the strategy. So we create something called a matrix. A matrix is a two-dimensional array. So in our case, it will basically map up with each OS will run against each suite here. They'll be paired together as it goes through. Okay, we may choose to exclude or only include certain use cases. So if we go down to the include here, you'll see when it comes to Ubuntu 2004, we're only including OpenJDK 14. Whereas on Debian 9 and Debian 10, we're specifically excluding individual suites that we know do not work on those machines and those operating systems. But we want the rest of the test to run, and it's easier to show a very defined, I'm only running this test, or I'm specifically excluding these tests. So the other thing we do here is fail fast is false. What fail fast says is if I detect an error, I exit the job. For integration tests, we want to run through all of them in one go before we fail, because maybe we fail on Ubuntu 2004, but maybe we're also failing on Debian 10. And it'd be really bad if we have to fix Ubuntu before we can see the next failure. It's just slowing down that feedback cycle. And as developers, we want a fast feedback cycle. We want that information sooner. But now we've defined how we're going to run it, let's see what the actual steps are to run. Once again, we're going to check out the code. That's common. Then we're going to install Chef. So Actions Hub, which is another org I'm part of, has created a specific action to install Chef on the build machine. So each build machine is unique. It's given to you for that run, and then it's disposed of, wiped, and reset. After that, we're going to run the test kitchen action, but we're going to run it with a Docker driver. The Docker driver is fairly unique. Whereas most traditional drivers such as Vagrant use full virtual machine images, Docker uses Docker to create a stubbed operating system. So in that case, I mean, we'll have a Ubuntu container, but we will have most of system D in it, and it's usable for the majority of tests. There are certain scenarios we found where Docker doesn't work, such as SE Linux. But for the majority of our use cases, we use Docker because it's fast, and we're all about speed. We're all about that feedback cycle, okay? And then where we have set this matrix above, where we've got an OS and a suite, and we've decided which ones in the two-dimensional array will get excluded and included specifically, we then pass these in as the variables here. So what this will do is the test kitchen action will go and create a single job for each and every single one of those combination, and then it will run them as fast as GitHub Actions can, which in open source, they will give us 30 runners for free. So that's brilliant for us. I know that you can pay for more, and I know that if you are paying for GitHub and using closed repos, you can choose to pay, but this is just really good for us because we're getting whatever we need. But we're not waiting on Docker to finish before we do macOS. We're doing a very similar thing there. We are once again pinning on the fact that Markdown lint, YAML lint, and delivery have finished. And this time we're saying it's going to run on the latest macOS. And again, we're going to go through those same steps. We're going to go through checking out the code, installing Chef, and then running Test Kitchen. But this time we're going to use the macOS kitchen YAML we've defined. So because kitchen YAML will inherit, we have a root kitchen, which will normally be configured to use Vagrant. And then we have separate override ones for macOS and for Docker, just to change the drivers and the smallest parts that we need to change in order to function. But what we see here is that we're not just running Test Kitchen in the same way we ran before. This time we're only running up to the converge action first. So for those who aren't aware of Test Kitchen works in a create, converge, verify, destroy, or it has another command called test. Test is the default within the actions here. So if we do not specify the action, it'll run test, which basically runs the create, converge, verify, destroy as one action. But the reason we need to do converge here is that for Java on Mac, we need to run an inline script. It's just part of how it works. So here you'll see, instead of running a predefined action like we have above with the name and usage, we're going to run a specific script. It's bash. That's the default on macOS. We can choose to run different script types as well. And in there, we will just write the script in line. After that, we'll run the verify step, which will go off and run inspec on the machine and do the integration tests afterwards to confirm that what we've installed is what we want. So let's be fair, this is all nice and all, but how does it actually work under the hood? So if we go to this lovely commit, which is called break builds for webinar, because I'm very creative and imaginative, I've made a commit here that will break the builds. So the first thing we'll see here is that each of the jobs were listed under the CI file are listed here. Okay, there are some others in here, please ignore them for now. But you'll see when we get down to Docker how it's split it out. So our OS and our suite, we can see those inputs here. So we can see on the left the OS, on the right the suite. So we can go through them, and you'll find that some of these haven't worked. So this is actually because the checksum's wrong on the commit here. Okay, so if we go into them, you'll get a page like this. You'll expand Docker, and you'll scroll down and you'll see the standard test kitchen errors. So the checksum doesn't match. Okay, so that's why the build's broken here. This is great, but there's also another thing that we don't normally talk about too much in code. What about warnings? What about things that are flagging in our linting or in our unit tests that are, hey, you really should fix this, but it's not an error. And if you're like me, I don't go and read passing checks in GitHub. I only read the ones that fail. What GitHub Actions does is it gives us something called matches. So these give us a check annotation, and these mean that we can see things like this of setting unified mode as a warning. So, hey, we've not touched this code at all, but be aware that this is a change that you should make. We're not failing the build. We're just saying that this is something you want to do. But also, if you do have failing tests on things like Rubocop, Cook style, or RSpec, again, you can get the same style of warnings or the errors themselves in here on the exact lines that need to be changed. So in this example, it's at the top just because the line doesn't exist at all. But if, for example, there was an error with this line here, or Java, this is wrong, it would put the line right there. The reason it's not come up as an error is just a bit of bad coding on my side, unfortunately. The test is still passing, and I do need to go and figure out why after this session. But that's it for the demo. So back over to you, Heather.
Okay, I think I'm back and I'm sharing.
Yes, we can see the PowerPoint locally on your machine.
Okay, awesome. Very good. Cool. Okay, just a quick wrap up. And I know we have a lot of activity going on in the chat, in the QA with questions for Jason. So we'll be getting to those in just a second. We've got 2 of the repositories listed here that Jason was showing off in the demo. I can again put those links in the chat so you all have them. Not very useful on a PowerPoint slide. Also want to mention Chef Infra Client 17 released on April 28th. If you are not aware, we have a recorded webinar of the release, which product manager Tim Smith and his awesome live balloon drop here went over the key features of Chef Infra 17. We also shared an amazing video that celebrates the chef community during that launch. If you haven't seen it, take a look. It's on YouTube. And also want to mention, if you're looking to stay on top of the latest releases of Chef, they're here on Discourse. It's a great page to bookmark. You can read the release notes. They come from product management. Stuff's going up every week. And then the last thing I want to mention is ChefCon. Woohoo! Is coming soon, September 7th to 9th. In addition to the registration being open, we also have the call for speakers. If you've done something cool, or if your company is seeing some amazing value or results with Chef, definitely encourage you to submit your idea through the call for speakers. So with that, then, Jason, did you want to start looking at the chat and the questions?
Yeah, so we'll go with the first one, which is, what does Chef Delivery do? So if I can just take over screen sharing again a second. So Chef Delivery is just a simple abstraction on some commands we're going to run. So for us here, it's abstracting the RSpec and the cook style. This is partially because of my own laziness. When I want to run these, I forget the exact syntaxes to use or to put the spec / in. So I have a little alias set locally, which runs chef, exec, delivery, local, all. All stands for every single phase within this file. So it's going to go through the unit, then it'll go through the linting. And if one fails, it will stop there. Again, just down to my own laziness, that's all there. On to the next question of what about Docker Hub image chef workstation instead of Ubuntu latest? So that's, I probably didn't explain this correctly, which is my own fault here. So we are using Ubuntu latest here. That's not a Docker image. That's an actual virtual machine that is supplied by GitHub, and that's just how they've chosen to name it. We do use the chef workstation image within the chef delivery here. So under the hood in Actions Hub, what they do is they take the chef workstation and then they get it to run the chef workstation Docker image, and then they get it to run the entirety of delivery on top. In some of these use cases, we just can't run chef from within that Docker image. It doesn't work for things like Test Kitchen within the limitations of GitHub Actions, which is why we do the install and then we run Test Kitchen. That's it. I'll take a couple more questions and then I think we'll probably call it, and others I will answer afterwards, potentially in the community. So Jake's asked, could I provide some reference for getting annotations for output setup / configured correctly? I can. I believe after this, we're going to be putting up a blog post. So I'll ensure that information is in there just to make it easier to disseminate. It's very much part of the initial setup of the actions. So I will make sure that that is put into there. Carl has asked, do you have any concerns about using a CI tool, GitHub Actions, which is so tightly tied to the source control system, GitHub? This would make it more difficult to migrate to an alternative source control system, e.g. GitLab, if you needed to for any reason in the future. Yes, that is true. It will make it tightly coupled. But for me in sous chef and with open source, let's be honest, open source basically lives on GitHub nowadays, whether or not we all agree with it, that's the default place. And I think if I'm going to be in a VCS and I'm going to have a build system, it would be really good for them to be extremely tightly coupled because I get the best benefits. However, GitHub Actions is not too dissimilar from Azure DevOps, from Circle CI, from these other pipeline as code tools, that I could take what I'm doing here and apply that same logic to another tool. It would be some engineering effort to expend. It would take some time to get there, but there's nothing to stop me migrating apart from time. But I truly believe that having this tight coupling where I'll get the warnings, I'll get the errors inside the code as I'm reviewing it as well, is of benefit to us, at least in sous chefs with the open source work we're doing. And final one I will take for today is, please pardon my lack of knowledge in GitLab, GitHub, but I noticed you were using GitHub with ci.yaml configuration. Is this the same as GitLab with the GitLab-ci.yaml config? It's not at all. They're separate things. We decide, so the naming of this file, the only convention is it must end in .yaml. We just decided to call it CI because it seemed sensible as it's what it does. It could be named foobar, it could be named anything you want .yaml in there. It's just a chosen convention we've done within sous chefs. But yeah, the other questions, I will be available in the community for Chef after this for a little bit if you want to reach out in there. So if you reach out in general, or there's channels like Sous Chefs or Actions Hub, I'm normally in, happy to take some more questions there. Heather, back over to you.
Awesome. Thank you, Jason. Thank you for the awesome demo and your time. And as Jason mentioned, he'll be available on the community chat for more questions. His tag in the community is Exerma. Is that how we say it?
I'll put it in chat.
Okay, in case you don't know. Awesome. And Jason will be following on with the blog. With that, feel free to reach out to myself or Jason if you have any other questions regarding any of the resources or upcoming events and activity at Chef. And with that done, we'll just thank you for your time today and joining us, and hope everybody has a awesome evening or day. Reza, we can go ahead and close the event.
Sure. Thanks, Heather. Thanks, Jason. It was really a great session. So we hope you all find value in all the information that was presented today. If you liked what you saw, we encourage you to share the presentation with your teammates and professional network. So the on-demand version should be available very soon. We will email it to you as soon as it's ready, and you will be able to access it using the same audience link you're using now. So with that, thanks again for attending and have a wonderful rest of your day. Thank you so much. Thanks, everybody.